Hello, here's a video for day 7. I have posted my class notes for this, so I'm not going to go through these examples. I've tried to show plenty of workings. I really strongly recommend that you do this activity, investigate this. I know some of you will have looked at this transforming our sine curve last year. If you need a quick refresher, I would work through that. I have worked through your notes. So they're all downloaded, so do have a little look at this activity on your own. Maybe pause the video and try that. You can see my notes for how I filled this in, but maybe we'll take a look at a couple of these just together. So we're trying to find what the parameters are for the trig equation of this curve. I'm going to stick with a sine curve. I guess you could use either. The reason I'm going to go with a sine curve is that I can see this looks like it starts around its principal axis, goes up and then down, which is exactly what a sine curve does. If it had been translated over and started at a maximum or at a minimum, I would probably pick a cosine curve, but you can use either. So the first thing I always try and do is figure out where my principal axis is. Now, you might be able to do that just by counting, kind of figuring out where the middle between the maximum and the minimum are. I think with nice whole numbers like this we can. Or alternatively, you can think, oh, well, I'll find the midpoint. I'll add 5 and -1 and make 4, and I'll halve it and get 2. So our midpoint is here. Let's just draw that in. So that is our principal axis. And our principal axis is actually D, so that's quite helpful. So let's have +2 straight away. And the principal axis is good because it helps us find the amplitude, of course. So the amplitude is the maximum height above the principal axis, which we can see is 3, and that's our A value. So the Y transformations really are quite the most straightforward. You'll see formulas for finding A, where you're finding the distance between the maximum and the minimum and halving it. I think once you've drawn in the principal axis, it takes away the need for any of that. So next, let's just get rid of that. We found A, we found D. We now need to find B and C. So I use a formula to find B. B equals 2 pi over the period, or if you're working in degrees, 360 over the period. We haven't been given any instructions as to which we should use here, so we can really use either. As radians are the least familiar, that's what I'm going to use, so we get used to that. So what is the period? Well, the period is how long a whole wavelength is. So looking at this axis, 20, 21, 22, 23, 24. So the period is 24. So my B value is 2 pi over 24, which is pi by 12. Okay, so that is pi by 12. And then finally, what is my C value? How much has that y-intercept been moved left or right? Well, the y-intercept on a sine curve would be 0, 0. So as we've shifted up 2, it would be 0, 2. And I can see that it hasn't actually moved anywhere. So here my C value is 0. So let's write that out nicely. F of x equals 3 sine pi by 12. I don't really need these parentheses here, do I? Let's go. Doesn't make a difference if we have them or not. Okay, +2. And of course you can put that into your GDC. Make sure you're in radians mode, and you should, if you set up your window, it should look identical to this. And while you're starting out doing these kind of questions, it's a really good way of checking things to make sure, am I in radians or degrees? And then really, I think the trickiest ones are the x direction transformations, B and C. So we'll look at maybe one more of these. I think this is page 21 of your booklet. And yeah, let's do the top one. And maybe we'll do it in terms of sine and cosine, just so we see both of those. Okay, so I'm starting with the principal axis again. We haven't got loads of information on here, maybe partly down to how it's printed, but let's see. So it's going from 0.5 up to 3.5. So principal axis is going to be halfway up there, which is 2. If you're not happy doing that by just thinking about number lines, you can do 0.5 plus 3.5 is 4, and half it is 2. So that's going to go through here, and drawing that in, that looks good. The amplitude is the next one. That's nice and easy. If we were at 2 and we're going up to 3.5, that's 1.5. So A equals 1.5, D equals 2. Next, I'm going to work on finding out my B value and C value. So let's find a full wavelength. If I go from here, oh, hang on, I don't have any scale that's going to help me. So maybe I'll use the coordinates I've been given. So going from a maximum, where the x-coordinate is 3, to a minimum, where the x-coordinate is 5, I've increased by 2, but that's only half a wavelength. So to complete the wavelength, I'd need to go another 2. So my period is 4. So B, I'm going to stick with radians, I think, 2 pi divided by the period, so B is pi by 2. And then finally, what has happened with my the point that I would expect on the y-axis? So I would expect this to be the start of a sine curve. It's on the principal axis, and then it increases from there. So this should be on the y-intercept. What's happened to it? It's been moved across. It's been moved to the right. How much has it been moved to the right? Now, this is a little bit tricky because we don't have much of a scale, but we've been given these 2 points. So I can see a maximum was at 3, a minimum was at 4. Halfway between a maximum was 3, a minimum's at 5. So this halfway point must be 4. So if you like, a quarter wavelength is 1 unit on the x-axis. So this must be 2. And continuing that logic just to make sure, 1 and 0, that seems to make sense. So my C value, I've moved to the right, so I'd have x minus 2. C equals 2. So my function is y equals 1.5 sine pi by 2 x minus 2 plus 2. Lots of 2's. Let's just sketch that on my calculator. So 1.5 times sine pi by 2 times x, hang on, I've lost it now, where is it? Minus 2, and then let's go here for plus 2, and I don't really want that anymore. Okay, thinking about my, I need to be in radians, and let's have it roughly the same as this. 4, 5, 6, 7, 8. And they've gone up to 3.5, so let's make sure my range goes high enough. There we go. Let's see, so it starts by going down. Yep, this looks good. And let's just check those 2 points they gave me. So if I wanted to be really precise, I could do the extremum to get them 3 and 3.5 and roughly 5 and 0.5. Yep, I'm happy with that. If this was cosine rather than a sine curve, if we've been told to use cosine or we'd chosen to use cosine, what changes? The amplitude does not change. The principal axis does not change. The B value does not change because it's still the same period. It's only the C value that's going to be different. So if I was doing this as a cosine graph, I would be expecting this point to be on the y-axis because that is the top, that's the maximum. So all that would be different, obviously, instead of sine, I'm going to write cosine. I've still got the same B value, but now I've shifted it over 3 units. Okay, so that's the only difference there. Right, I've put answers for the second one in so you can give that a go and check them on its learning.